So this is video number 4 in a series of 9 videos to try and help you to master the number patterns questions in the IB NYP exam. So here we've got a number pattern. So it's a sequence called S, and when n equals numbers 1, 2, 3, 4, 5, 6, 7, 8, so position in the sequence, then the numbers in the particular pattern are 4,374, 1,448, 486, 162. So what's going on here? Well, first of all, we need to see if it's going down by a fixed amount every time. So if we just try kind of subtracting one term from the next, are we getting the same thing every time? And in fact, we're not. So we need to see if what happens if we divide these out. So if we do 4,374 divided by 1,458, are we getting the same as dividing 1,458 by 486? And indeed, that is what's going on here. To get from one term to the next, you're dividing by 3. Now, dividing by 3 is the same as multiplying by a third. So to get from one term to the next, we're multiplying by a third, and that's going to be the basis of getting our rule. So let's just think about patterns in words. So each term or each number is the previous one divided by 3. So that would be an obvious one. So let's try and fill out the table. So 162 divided by 3, 54. Divided by 3, 18. 18 divided by 3, 6. 6 divided by 3, 2. So we could make the observation that all numbers so far are even. Of course, that's not going to carry on because the next one's going to be 2/3. So anyway, let's go about trying to find an algebraic rule for this. Well, let's just get rid of this. So the first term is 4,374. The second term is 4,374 times a third. The next term is the previous term, 4,374 times a third times another third, so times a third squared. The next term is that times another third, so it's 4,374 times a third cubed. And hopefully you can start to see the pattern there. It's generally always 4,374 times a third to the power of something. And that something is always one less than where we are in the sequence. So the 100th one, for example, would be 4,374 times a third to the power of 99. And generally speaking, we can write that the algebraic rule is that S equals, and don't forget to write it as something equal to something else, S equals 4,374 times a third, times a third to the power of n minus 1. And generally, a geometric sequence is always the first term times the common ratio to the power of n minus 1. Okay, so testing and verifying the rule. So testing is just taking one of the early values in the table where they've given you what S is supposed to be and checking your rule generates that number. So when n equals 3, My rule says S equals 4,374 times a third to the power of 3 minus 1, which you can stick in Desmos actually and just paste the result of that, save you a bit of time, but which does equal 486, which matches the value in the table. So that calculation clearly expressed. Maybe you want to put in one more line of kind of intermediary calculation with the comment observing that the number you get from that matches the number you expected to get in the table. That should get you the marks for that. And then verifying it's almost exactly the same, but you're just doing it for one of the higher up values in the table where you actually made a prediction yourself. So when n equals 7, my rule says that S equals 4,374 times a third to the power of 7 minus 1, which is 4,374 times a third to the power of 6, which is 4,374 divided by 3 to the power of 6, which, stick it into Desmos if you like, comes out to be the value we predicted, 6. And then you just want to make the final observation. I'm just going to sneak this up there so that I can copy and paste this bit that says which matches the value in the table. Copy and paste that over there, get rid of that and put that there. And that's pretty much job done for that question.